Okay, so this is the video with my answer response for midterm 2, and then top right you can see my name. So question 1. So what question 1 is asking, it's to compare the small angle approximation of sine x to be equal to x. And basically what I did was I plotted both functions, and then I found the error between, and then I also determined how small x can be approximated when it stays within the 5% error. So you can see right here on the blue line that it is the sine function, and then x is just, sorry, yeah, x is red. And the simple explanation of the code was I did line space, which creates many value between 0 and 1, because that is the given parameter that we are using for this question. And then secondly, I did plot, which graphs the actual sine function and the approximation. I also use the code hold on, which lets both of the sine and the x graphs appear as well. And I used fine as well. Let me see if I can. Oh yeah, I use fine as well, which locates the error first that becomes larger than 5%. And I use printf, which prints out the final answer. And the final answer is the approximation is accurate within 5% until about 0.55 radians. And then we can see on the first graph, it's just the simple sine compared to the x function. And then the second is the approximation error. The third will be the relative error. So you can see, sorry, wait, no, not that one. Right here, this is the approximation error, and then the third graph will be the relative error as well. So moving on to question 2, is asking us to look at all the data points that we're given for both x and y, and then we have to choose which function will fit the best. So what I did was I stored all the x and y values, and then I also use polyfit, which would find the best power function. And then I would also plot both the original and the fitted curve. So this is the original, the red dots, and then the fitted curve would be the blue line. And then I would also calculate the fitted curve, plot both the original and fitted curve, which is right here. So that's what we have. And then I'll also print out the equation. Okay, the equation didn't print out, but I'm gonna read out the answer in a second. But a simple explanation of the graph is that the red dots are the original data, which I said before, and then the the blue curve is the fitted power function. And since the curve follows the points closely, it is I would say it's a really good model. And then the answer is the best model is the power function, because the data increases faster as x increases. We got part B of question 2, which is asking finds well, it's basically the same for all 3 parts, which is to find the best equation that describes the data. And a simple explanation is I entered the data again. I used polyfit to find the best straight line, and then also plotted I also plotted the data and the line, which as said before, the red dots are the original data, and then the blue line is the fitted graph function. And yeah, the answer for the second part is that the linear function fits the best because the data, it's pretty constant. And it's decreasing at a constant rate. Is what I'm trying to say. Part C. Wait, let me pull up. Okay. Yeah. Part C is asking to determine which type of function best matches the data. So what I did again was I entered the data. Sorry, I entered the data, and then I used polyfit on the logarithm of the data, and it was able to find and use the exponential fit, which obviously using logarithm, that's what you're going to use. I mean, that's what you're going to get. So, and then I plotted the exponential curve, and then I printed the function as well. Let me see. So simple explanation of the graph is the data drops quickly at first, which you see right here. It starts at 40 and then it drops down to 20, and then it decreases a lot slowly. So from around 18, it decreases to about 8, and then the exponential curve matches the pattern. So you see right here, it drops down really quick and then it slowly reaches the bottom of the x-axis. The answer for part C of question 2 is that an exponential function fits best because the data shows an exponential decay. Going on to question 3. It's asking to create 2 histograms, one showing the number of observations and one showing the amount of percentage of observations. Basically what I did was I stored all the data that was from the MPG, and then I used histogram and then close parentheses, which would make the first graph. Okay, yeah. So there's 2 graphs. This is the first one. This is the absolute. So I'd make the first graph using the histogram, close parentheses, and then I would use, let me pull up the second graph, a histogram, ... on normalization and probability. And then I would close parentheses to make the second graph. And then to explain the first graph, it shows how many cars fall into each MPG value. And the second graph, let me see if I pull up. The second graph shows the same information as a percentage instead of counts. And then the answer for number 3 is the histograms helps us see which MPG values occur the most when the data is distributed. And lastly, question 4. Question 4, it's asking to estimate the missing temperatures between 5 p.m. and 9 p.m. using linear interpolation. So simple, what I did was I entered the known temperatures, which we see right here. That's underneath the known time, and what I did was I used enter 1 to estimate the missing values, which I was able to do because because we have already a given amount of temperatures, we can use enter 1 to sort of estimate what the missing values could be. And I plotted the known data and the estimated points. So the known data is the blue line, and then the interpolated, which was from the given temperature values, that's going to be the red squares as well. The answer is that the estimated temperatures of 5 and 9 p.m. are 22. So for 5 p.m. it's 22.5 Celsius, and at 9 p.m. it is 16.5 Celsius. And that is all. Thank you.